Okay, for this question, we're given this differential equation, and we know the solution is y equals f of x plus c, and the goal is to find out what f of x is. And of course, because we have the answer options, we can just differentiate them and see which one is the answer. But let's see how we can actually do this in a direct way. And the key for this is you have to know how to differentiate / integrate absolute value of x. Here we go. Notice on the right hand side we just have in terms of x. So you can multiply both sides by dx first. So dy equals, right here, absolute value of -6 is just 6. And we still have to keep the absolute value for the x like this, and then we have the dx. Now usually we can just go ahead and integrate both sides. On the left hand side we get y plus a constant, but on the right hand side we also have a plus constant. Combine the constants is another constant, so I'm not going to bother with the constant here, just put down a plus constant on the right hand side. Now the question becomes, how do we integrate absolute value of x? Okay, notice when we have absolute value of x, this is the same as square root of x squared. And usually we like to go from here to here, right? Because when we cancel the square roots of square, we get absolute value of x. Today, we're looking at this as that, because it's easier to differentiate this right here. Why differentiating this though? Well, if you want to integrate this, it's going to be the same as integrating that. But I still cannot integrate this. So instead, let me try to differentiate this instead. When we're trying to differentiate one part of an integral, we should integrate the other part, right? So that's what? Integration by parts. And we'll do the di set up for it, plus or minus, around the side. I will differentiate this, and then integrate 1. Integrating 1 gives us x, and differentiating this, square root will give us 1 over 2 square root of the inside, and then use the chain rule, multiply by 2x, 2 and 2 cancel. So this times this, it's the first part of the answer, x square root of x squared. And then we still have to multiply these two things and then put that inside of an integral. That's a minus integral x times x, which is x squared, over square root of x squared. Now, this right here looks more complicated compared to the original, but in fact, they are the same. Right here, let's multiply the top and bottom by square root of x squared. It's a typical rationalizing the denominator. On the bottom, this is just what? X squared, which is just the inside. And right here you have x squared. You can cancel them out nicely. And now, let me rewrite this as the integral absolute value of x dx is equal to x absolute value of x minus, this is really the same as integral of just this right here, right? Just this, which is absolute value of x dx. This and that are the same. Let me add this to both sides. So we will get 2 of the integral of absolute value of x. That will be equal to x times absolute value of x. And then divide both sides by 2. Integral of absolute value of x dx equals 1/2 x times absolute value of x. And you can put on the plus c right here, but doesn't really matter. I'm going to come back here and do it. So here we have the 6. And then for the integral of absolute value of x, that's this, which we will get 1/2 x absolute value of x. And then I'll put on the plus c. And then finally, this times that is just 3. So y equals 3x absolute value of x plus c. And of course, this right here is our function, f of x, and that's 3x absolute value of x. And we are done.